We know that to solve a triangle means to determine all missing angles and all missing side lengths. If we take a look at the diagram below, so we have a lake and we have two triangles drawn over top of that lake. We're given the length of side AB, or lowercase c. We're also given two angle measures. So are we able to determine the missing angle measures and missing side lengths? Well, we could figure out what this angle is because we know the sum of the interior angles in a triangle is 180, so we could get that angle. But then beyond that, there's not much we can do at this point because neither this triangle nor this triangle is a right angle triangle. And up until this point, you're only able to solve missing sides and angles on right angle triangles. So we need a different strategy. And one of those strategies that we can use is what we refer to as the sine law. The sine law can be used on any oblique triangle. So an oblique triangle is a triangle that does not contain a right angle. Take a look at the sine law here, and I want you to notice a couple of things. In each of these ratios, we always compare the side length to the angle opposite from that side. The side length to the angle opposite that side. We know that we use a lowercase letter to represent the side length. A capital letter represents the angle opposite from it. We can also invert all of those ratios and get the second version where now I've got the angle measures on top. And again, the angle is always opposite from the side length across from it. The second thing you're going to notice is that if we go with this version of the sine law, we keep all side lengths in the numerator, all angle measures in the denominator. In this version, we put all angle measures in the numerator. We keep all side lengths in the denominator. When we go to solve this algebraically, it's easier for some people just to put what we're looking for in the numerator. It doesn't really matter, but if we know this is a side length, we can use this form to determine any missing side length in our triangle. If we know that these capital letters refer to the angle measures, if we put that in the numerator, we can use this version of the sine law to determine any missing angle measures. The other thing you're going to notice is that we always take the sine of that angle, which is why we refer to this as the sine law. We have here an oblique triangle. I know that this is side A, opposite from angle A. This is lowercase side C, opposite from angle C. And this is side B, opposite from angle B. I'm going to create right angle triangles by drawing in the height of that triangle. And we know the height goes up at a 90-degree angle so that I can show you how the sine law is derived. All right, so I've now created two right angle triangles. If we start with this triangle on the left, because it's the sine law, I'm going to use the sine primary trigonometric ratio, which we know is the opposite side over the hypotenuse. So I'm going to start with angle A, and it doesn't matter, I could do this in any number of ways, but this is just one way you can go about getting the sine law. So if we take angle A as our reference angle, we know the side opposite that is H, we know the hypotenuse of this triangle is B. So I can set this up here. The sine of angle A is the opposite side divided by the hypotenuse. Now I can do the same thing using this triangle on the right-hand side, taking angle B as my reference angle. From angle B, this is my side opposite. Oops. This is the hypotenuse. So I can set up that trig ratio and say the sine of angle B is the side opposite divided by the hypotenuse. Now you're going to notice if you go back and take a look at the sine law, H shows up nowhere in the sine law. This is just helping us to get to that sine law. So if I know ultimately H doesn't appear, I'm going to isolate H. And the way I can get H isolated is by getting rid of this B. And over here, I can isolate H by getting rid of that A. So right now we're dividing by B. The opposite of that is to multiply by b, and I'm going to multiply both sides by b because in algebra, what we do to one side, we have to do to the other. So I'm just algebraically rearranging this. Same thing over here. I'm going to get rid of this a, which I'm currently dividing by a. I'm going to multiply a. so that's going to cancel out. And then I'm going to multiply this side by a, so my two sides remain balanced. I know when I do that, a divided by 1 over a is 1. B divided by 1 over b is also 1. And then I end up with just b times the sine of a is equal to h. And I notice over here that a times the sine of b is equal to h. Now, we have two h's in these two equations. And again, we know h doesn't show up in the final equation. So in mathematics, if we have two sides equal to the same thing, we can bring those two sides together because we know they're equal to each other. It's what we call the transitive property. So if this is equal to h, and I know that h is this, we can go in here and say, therefore, those two sides must be equal. So b times the sine of a must equal a times the sine of b. And we refer to that as the transitive property. When two sides are equal to the same quantity, therefore, they must be equal to each other. All right, so now take a look at what the final sine law looks like, and we're going to algebraically do a lot of rearranging to get it into that formula. Okay, so let's start by saying we want the side lengths on top. So if I want b on top, I'm going to get rid of this sine of a by dividing it out. Right now we have b times the sine of a, so I'm going to divide out the sine of a. And again, in algebra, what you do to one side, you need to do to the other to keep it balanced. So if I go the sine of a divided by the sine of a, that's 1. So that's going to leave me just with b on the left. And then on this side, I've got a times the sine of b divided by the sine of a. So we're getting closer to the final version. We've got side a divided by the sine of angle A. So we want that. We don't want this sine B in here. So in order to get rid of that sine of B, we're going to divide that out. So I'm going to divide out the sine of B. And when I do that, I have to do the same thing to the other side. And this is good news for us because we want side length B divided by the sine of angle B. So on the right-hand side here, we know the sine of b divided by the sine of b is 1, so we can cross that out. And then pull this together. We've got b divided by the sine of b is equal to a divided by the sine of a. It's in a different order than my sine law that we looked at previously, but that's okay. What we're looking for is always just to make sure that the side length is divided by the angle opposite from it, and the side length is divided by the sine of the angle opposite from it. That's the goal. And you'll notice we only have 2 of those ratios equal to each other. That gives us a proportion that we can solve by cross-multiplying. We don't need that third ratio. That just shows us that no matter how I were to take these triangles up here, I could rearrange the different letters, and we will always get the same thing. A side length is divided by the sine of the angle opposite, and that ratio is the same for all 3 pairs in our triangle. In the first example, we're not given a diagram, so we have to first of all sketch this out so we can visualize what's happening. We know that we have triangle ABC. We're given side length C, side length A, and angle A. So this is not going to be drawn to scale, but we want a rough sketch. You're going to want to get into the habit of taking an angle measurement, if you're given an angle measurement, and putting it on the bottom left-hand side. We're going to call this the base angle. And the reason we're going to get into the habit of doing it this way is because there's something called the ambiguous case of the sine law, if you go on to different levels of mathematics. And by getting in the habit of putting your base angle here, if possible, it makes that next piece a little bit easier. Okay, so I know if I put angle A here, side A has to go across from it. So I'm going to fill in, we know side A is 12 units, so I'm going to fill that in. And the only other measurement I'm given is this side C, and it doesn't matter where you put it. So I'm going to put it, I don't know, maybe here, even though this isn't drawn to scale. If this is 12, this is my smaller side. And again, you could stick it anywhere. So this is going to be 6 units here. And if I choose to put side C there, I have to put angle C up top, which by default means this is angle B, which means side B is opposite from it. We are ultimately looking for the measure of angle C. So angle C is going to be up at the top there. So I'm going to use theta just to show that's the angle we're ultimately looking for. In the sine law, we're going to put what we're trying to find in the numerator of our first ratio. And we remember that angles are always attached to the sine. So I'm going to set this up and say, okay, so the sine of angle C is opposite side length C, so that's going to go on the bottom. And if I start by putting an angle on top, I have to continue with an angle on top. And remember, you're looking for a pair of opposites. Here is my pair of opposites. I only can have one variable in my sine ratio, otherwise I can't solve it. So my next ratio that I set up here cannot have another variable in it. So this is the only pair that has 2 known quantities. I cannot go with this, because I don't know side B, I also don't know angle B. So if I have 3 variables in my ratio, I can't do anything with it. So you're always looking for those pairs of opposites, and here is our pair of opposites. So we have an angle on top, so I'm going to continue with the sine of an angle on top, and on the bottom, 12 units is opposite from that angle. And then we are going to cross multiply, similar to what you did with your primary trig ratios. We're going to multiply the 2 sides opposite each other, diagonal from each other, that we know, and we're going to divide by the remaining one. Okay, so I just grabbed my calculator and pulled it up here. Remember, we want to be in degree mode. So when I go to type this in, I'm going to start by going 6 times the sine of 83, and then I'm going to press enter because I want to get that value of that product before I divide by 12. So now I'm going to go divided by 12 equals. All right, so that's the ratio comparing those side lengths. Now, I want ultimately the sine of that angle. So remember, we always find the missing angle measure by taking the inverse. So now we're going to go second function sine, second function answer, and that's going to put this whole value in there, and we're going to press enter. And then check how we're rounding. If it doesn't say, we're going to round to the nearest degree, but in this case it does say. So to the nearest degree, this 7 is going to bump that to 30 degrees. We know angle C is 30 degrees. In our second example here, again, we want to draw a diagram to be able to set this up. I'm given 2 angles in this one. Choose one of them, and again, we're going to set that up on the bottom left as our base angle. So 36 degrees, I just kind of sketched roughly and put in 36 degrees. And if I choose to put angle P here, this has to be side P across from it. You could have put angle R here too, in which case this would have then been side R. And again, you can choose. You can put the second angle R either at the top here or on the bottom right. I just chose to stick it here. But if I put it there, I know that the side opposite from it has to be side length R. So then by default, the only other side left is Q, which we're given the measure for here, so that's going to go at the bottom. And opposite from side length Q has to be angle Q. So we're going to set the diagram up first. Take a look at what we're looking for. So ultimately, we're trying to solve for side length R. So we know this is side length R, and we know this is the angle opposite from it. So if we set this up here, I know that R is opposite, and I'm going to take the sine of that angle that's across from it. Now, if I'm going to start with the side length on top, I'm going to continue with the side length on top. But remember, we need a pair of opposites. And we're going to have a bit of a problem here because I've got this pair of opposites, but I don't know P. I've got this pair of opposites, but I don't know angle Q. But could we solve for one of those measures? We can't do anything about side length P, but we can find angle Q. We know that 180 degrees is the sum of the interior measures, and I'm already given these 2 angles. So what I can do first of all is say, okay, angle Q, I know if I take that 180 degrees, subtract the two angles that we already know, and then that's going to give me the measure of that third angle. So in this case, when I put this in my calculator, I'm going to get 96.1 degrees. And again, remember, we don't want to round off to the end. So I know that this is 96.1 degrees. Now I can set this up. So side length Q is 21.3, and I'm going to leave my units off to the end. And I always take the sine of that angle. And then we're going to cross multiply the two sides that we know that are diagonal from each other, and we're going to divide by that third side. Grab my calculator. So this time we're going to start with the sine of 47.9, and remember you have to close that bracket. We're going to multiply by 21.3, and then we're going to press equals. We need that product. We're going to divide that whole product by the sine of 96.1. And then because we're just looking for side length r at this point, that is side length r. Check how to round, and in this case, we are going to round to the nearest tenth. All right, so I went ahead and just filled that in there. So our final answer is side r is 15.9. Don't forget the units, centimeters. Some of the word problems you're going to encounter are going to have directions attached to them. We know if we were to draw a compass that we typically put north facing upwards, and then if we rotate clockwise, we're going to hit east, south, and then west. So an acronym that some people use to remember this is never eat shredded wheat. So that's one way you can remember it. The directions are going to be written like this. And so this literally says 45 degrees west of north. So when you go to draw that angle in, you're going to start by putting your pencil going north. And then we're going to rotate 45 degrees to the west and get that angle. The arm of our angle began pointing north, and we rotated that arm 45 degrees to the west. That's our 45 degree angle. In the second one, when we read this, we say 60 degrees east of south. So again, you're going to take your pencil and you're going to start pointing at south. We're then going to rotate that arm 60 degrees to the east, and that's that angle that we're going to fill in there. Our final example involves directions, and I'm going to help you get this one set up. So we start by recognizing Jeremy is currently at point C, but when I keep reading, I see that A is directly north of C. So I'm going to move down here and put C down here so that I can put A directly north of it. And if it's directly north, we know that this is going to be a right angle, and we also know all of those are going to be right angles there. I know that B is 105 meters in a direction of, now we read this, 41 degrees east of north from point C. So starting at point C, I'm going to draw my little baby compass here. I'm going to start my pencil pointing north, and I'm going to rotate to the east 41 degrees. So he's going to walk out here 105 meters, and there is point B. So we're going to get that filled in here. All right, so we've got point B going 41 degrees east of north. And we also know that B is 105 meters from C. So we can go in here now and say, okay, these two are 105 meters apart. We are ultimately looking for what direction is Jeremy going to walk going from A to B. So if I go back here and take a look, A to B is going this way. And again, we're going to begin pointing our pencil either north or south. Well, clearly if he goes north, he's not going to get to point B. So we're going to be going south. So I'm going to fill in, we're looking for south. And then to get to B, I'm going to be rotating to the east. So I'm looking for how many degrees east of south is he going to have to walk. This is not a right angle triangle. So every time you draw a direction picture, please try not to put any right angles in there, because then you're mistakenly going to sometimes assume things that aren't true. All right, so I'm looking for this angle. Good news is we know the side opposite from it, so I've got that piece of information. We also know that he's going to walk 70 meters from A to B. So I can also go here and fill in, this is 70 meters from A to B, and that then gives me this other pair of opposites that I need to use the sine law. So when we fill this out, we're ultimately going to be looking for that little angle there that I used a theta to represent. So I'm going to put, we're looking for the sine of that angle, and that is opposite from that 105 meters. If I start with an angle on top, I continue with an angle on top, and that 41-degree angle is opposite from 70 meters. So again, this is our proportion. We're going to begin by cross-multiplying the two opposite from each other, and then we're going to divide by that third known measure. Went ahead and multiplied that 105 by the sine of 41, and then divided that total by 70, and that gives me that ratio there. So we know the sine of that angle is equal to this. And remember, this ratio is the opposite side divided by the hypotenuse there. And then in order to solve for the angle, this is where we take the inverse. So second function sine, we want that little -1 there. And I'm going to go second function, press the negative key to put that previous answer in there. So it's going to take that whole value and put it in here. I'm going to press enter, and that gives me angle. It's going to be 79.76 degrees. And again, that's going to be east of south when we fill that in. Tell me what to round to in this particular question. We normally round degrees to the nearest whole angle if it doesn't. So if you filled in 80, that's okay. But we also can leave it as an exact value. So that's what I did in this case. So we are going to walk, or Jeremy is going to walk 79.7, etc. degrees east of south in order to get to point B.